Hi my dear students, Assalamu alaikum to all. Once again, I warmly welcome to all in my class. In the last class, we learned about Newton's first law. Is it? Yes. The first law of motion defines force and inertia. First law of motion defines force and inertia. Next, we are going to learn about how to measure force. We are going to learn about how to measure force. Yes, we know that what is the equation of how to find out momentum? Momentum P is equal to m into v. P is equal to m into v. Then the rate of change of momentum, how will you find out? Yes, let us see. Yes, we know that momentum m into v. The velocity of moving body changes from u to v when a force F is applied for t seconds, then the rate of change of momentum of body is equal to m into v minus u divided by t. m into v minus u divided by t. Is it? Rate of change of momentum is equal to m into v minus u divided by t. Because we know that momentum is equal to m into v. Here rate of change of momentum m into v minus u divided by t. Is it? Then when we applied force, then what happens this momentum? Is it increased or decreased? Yes. When force increased, momentum also increased. When force decreased, momentum decreased. Is it? Okay. So, what is the second law of motion defines? Yes, the rate of change of momentum is directly proportional to the unbalanced external force acting on it. What is the second law of motion? Second law of Newton's second law? Yes, the rate of change of momentum is directly proportional to unbalanced external force acting on it. Is it? Okay. So, therefore, here in second law said that F is directly proportional to rate of change of momentum. So, we can write F proportional m into v minus u divided by t. Yes, second law of motion defines force is directly proportional to rate of change of momentum. So, we can write force is directly proportional to m into v minus u divided by t. Is it? Yes. So, F proportional m A. What is A? Yes, A is equal to acceleration. We know that. How to find out acceleration? Acceleration is equal to v minus u divided by t. So, v minus u divided by t, we can write A. Is it? So, F is directly proportional to ma. F is directly proportional to ma. So, then to remove this proportional, what will do? Yes, F is equal to kma. F is equal to kma. K is the constant. K is the constant. Okay. If K is equal to 1, if K is equal to 1, what is F? F is equal to ma. F is equal to ma. If K is equal to 1, F is equal to ma. This is the equation to calculate force. This is the equation to calculate force. What is the equation? F is equal to ma. M is equal to m mass, A acceleration. How to find out force? Force is equal to ma. Is it? Okay. For that, all of you take page 52. You can see a question. What is the question? Yes, a car moving with a speed of 108 km per hour comes to rest after 4 seconds on applying brake. If the mass of the car including the passenger is 1000 kg, what will be the force applied when brake is applied? How can we find out the answer? Yes, let's see. Yes, initial velocity, that is u. Initial velocity u. What is initial velocity here? Yes, car moving with a speed of 108 kilometer per hour. 108 kilometer per hour. How to convert this into meter per second? Yes, you know, 108 kilometer per hour is equal to 108 into 1000 divided by 60 into 60. Yes, 180 kilometers converted by multiply 1000 and how to convert hour to second? 60 into 60. Okay, so we get, by doing we get 30 meter per second. We get initial velocity 30 meter per second. Then final velocity. What is the final velocity here in this question? What is the final velocity? Yes, comes to rest. Here says that comes to rest. So, final velocity is equal to 0. V is equal to 0. Then mass, what is mass here? Yes, 1000 kilogram. Mass 1000 kilogram. Yes. Time 4 seconds. Time 4 seconds. According to Newton's second law, what is force? F is equal to ma. F is equal to ma. M into A means V minus U divided by T. V minus U divided by T. Then apply these values into this equation. Yes. What will we get? Yes, what is mass here? 1000. Then what is V here? 0. U 30. Then T 4. Yes. All of you try to do. Yes. After that we get minus 7500. What is the unit? Newton. Because unit of force is Newton. Unit of force is Newton. Okay. Yes. All of you get this answer? Good. So, we get the answer F is equal to minus 7500 Newton. Minus 7500 Newtons. This negative sign. Here negative sign. Indicate what? Yes. Apply force opposite direction. Negative sign indicate opposite direction of motion. Opposite direction of motion. Is it? Okay. I think all of you understand. Okay. Like that all of you do the problem in page 52 and 53. Okay. All of you do? Yes. Next, you can see a question alone here. What is the question? M1 and M2 are the masses of two bodies. When a force of 5 Newton is applied on each body, M1 gets an acceleration of 10 meter per second square and M2 20 meter per second square. If the two bodies are tied together and the same force is applied, find the acceleration of the combined system. Find the acceleration of the total acceleration. You want to find out total acceleration. How to find out? Yes. Like that. We know that what? F is equal to ma. We know that force is equal to mass into acceleration. F is equal to ma. Then what is m1 here? What is m1 here? m1 here. We want to find out F divided by a1. Force divided by acceleration. First acceleration. Okay, what is force in this question? This question, what is force? Yes, 5 Newton force. 5 Newton force. So, we can apply 5 Newton. What is A1 here? First, you write what we given. 5 Newton. A1, what is A1 here? Yes, 10 meter per second square. What is A2? 20 meter per second square. F is equal to 5 Newton, A1 10 meter per second square, A2 20 meter per second square. Then apply this value, 5 divided by 10. What do you get? 0.5 kilogram. 0.5 kilogram. M1 we get 0.5 kilogram. Next M2, like that. What is the equation of M2? F divided by A2. F divided by A2, you get 5 by 20, that is equal to 0.25. 0.25 kilogram. 0.25 kilogram. Then what is the total mass? What is the total mass? M1 plus M2. What is M1 plus M2 total mass? M1 plus M2, we get 0.75 kilogram. 0.75 kilogram. Then we can find out total acceleration. Okay. Yes, total acceleration F divided by M. F5 divided by 0.75, we got 6.67 meter per second square. 6.67 meter per second square. All of you write this in your notebook. Okay. Next, we are going to study about what? Yes, impulse. Next, we are going to study about impulse. Yes, what is impulsive force? Impulsive force is very large force acting for a very short time. Impulsive force is the very large force acting for a very short time. Okay, so what is the equation of impulse? Impulse is equal to force into time. Equation of impulse is equal to force into time. Equation of impulse is equal to force into time. Then what is the unit of impulse? What is the unit of impulse? Yes, we know that unit of force is equal to Newton and unit of time is equal to second. Unit of force Newton, unit of time second. So, what is the unit of impulse? Newton second. Unit of impulse Newton second. Is it? Unit of impulse is equal to Newton second. Next, how can we write this? Impulse is equal to F into T. Impulse is equal to F into T. So, we know that F is equal to M into V minus U by T. We apply that. Impulse is equal to we know that F is equal to M into V minus U divided by T and into T. Yes, this T and this T are cancelled each other. Then we get impulse equal to M into V minus U. Impulse is equal to M into V minus U. That is, how can we write? MV minus MU. MV minus MU. Is it? Yes. This is the impulse momentum principle. So, change in momentum is equal to impulse. Change in momentum is equal to impulse. So, we can write that impulse is equal to change in momentum. Impulse is equal to change in momentum. Then impulse is equal to force into time is equal to change in. We know that impulse is equal to force into time. So, we can write impulse is equal to force into time. Impulse is equal to force into time. That is, force into time is equal to change in momentum. Okay, we will write. Impulse is equal to force into time. So, force into time F into T is equal to change in momentum. F into T is equal to change in momentum. That is equal to F into T is equal to constant. It is a constant. It is a constant. So, we can write that F is inversely proportional to time. F is inversely proportional to time. So, when the change in momentum is the constant, when change in momentum is a constant, what happens? Yes, force is inversely proportional to time. Force acting the body is inversely proportional to time. Is it? Yes. When time increasing, what happens? Force decreasing. Inversely means you can, when time decreasing, force increasing. When time increasing, force decreasing. Yes. Some situations are given in your textbook, page 54. You write the reasons for that. First, at the time of catching cricket ball, you can see that. At the time of catching cricket ball, the time of catching is extended by moving the hand backward with the ball. Yes, what's the reason of that? Yes, it's to when time increasing, we said that when time increasing, what happened? This force is very less, not very less. When time increasing, force decreasing. To decrease force, we extended time. So, like that all of you write other situations and its reasons also. Next, we are going to learn about Newton's third law of motion. Newton's third law of motion. Yes, we know that rockets are used for launching satellites. Is it? Yes. How this rocket working? How this rocket working? Let's see. For that, you can see a picture here, page 50, page 55. You can see a picture here. What is that? Yes. Let's make a balloon rocket. All of you try to make. Okay. Pass a long string through a straw and tie the string between two windows of the classroom or anywhere. Okay, like that. Paste an inflated balloon on the straw. Paste an inflated balloon. Is it like that? Deflate the balloon and release it suddenly. What do you observe? Deflate the balloon and release it suddenly. What happened? Yes, balloons move fastly. Balloon move fastly. Is it? Balloon move upward. Yes. Next, what is second question? Is in the motion of the balloon in a direction opposite the direction of the air? Yes. Is the motion of balloon is the opposite direction of the air? Yes. Motion of the balloon is opposite direction of the air. Air is moving this direction and balloon moving here. Balloon moving upward and air moving downward. Yes. Isn't this due to the force produced by strong release of air? Why this balloon move? Yes, by releasing that air. The force of that air, the balloon can move. If this force is taken as action, so this force is taken as action. Which force? The force of due to the force produced by strong release of air. Due to the force produced by that air is action. Here, action is force produced by air is action. Force produced by air is action. What is the reaction? The force that pushes the balloon along the string can be taken as reaction. The movement of balloon is reaction. The movement of that movement of air is action. The force that movement for air is action and the movement of balloon is reaction. Is it? Yes, like that there is another experiment. You can see that. What is this? Filling a boiling tube with some water. This is boiling tube filling with some water and close it gently with a cork. Close it gently with a cork like that. Suspend it from stand. Heat the boiling tube slowly. You can see that Yes, heat the boiling tube slowly. What will happen? What do you observe? He asked him, what do you observe? Yes, what will happen? Yes, the cork is pushed out. What happened? Yes, the cork is pushed out. Is it when heating that time this cork is pushed out? Yes, then is it not due to the force exerted on the cork by the steam from the boiling water? Yes, this boiling water when boiling this tube is boiling, that time cork pushed out, that time this tube move backward, that time the tube is moving backward. Yes, so what is the action and reaction here? Action is cork moving out. Action is cork moving out. What is the reaction here? What is the reaction here? Yes, this tube moving backward. This tube moves backward is the reaction. Is it? Okay. Like that, what are the action and reaction when we walk on the floor? What is the reaction and reaction? Yes, the floor exerted force. The floor exerted force is the action, and exerted force on the floor. Exerted force on the floor. Exerted force on the floor action, and the floor exerted equal and opposite for the feet reaction. Exerted force on the floor action. Yes, next the floor exerted equal and opposite reaction force on the feet is the reaction. Floor exerted force action on the time of we get the opposite and equal force on the feet is the reaction. So, like that, gas at high pressure pushed out the chambers of rocket. Yes, how this rocket move? Gas at high pressure pushed out chambers of rocket highly. Is it if the action of the force that propelled rocket forward? Is it? Yes, like that. Our action and reaction say. Our action and reaction say. Let's see. You can see that there is another activity. There are two digital weighing balance are connected as shown in figure. Yes, let's see. Yes, there are two balance are connected like that. If we push the A with the force 50 Newton, yes, that time what is the reading of balance B? If we apply force here 50 Newton, what is the reading on B? Same reading, is it? Yes, 50 Newton. 50 Newton reading is same. If the applied force is action, which is reaction, here action is we applied force. Applied force is action. What is the reaction? Reaction is reading. D is the reaction. Here, how much are the action and reaction here? Yes, action is 50 Newton, reaction also 50 Newton. Here we can see that action and reaction have a same value. Action and reaction is the same value. So, every action there is an equal and opposite reaction, and this is opposite also. So, we can say that every action there is equal and opposite reaction. This is the Newton's third law of motion. This is the Newton's third law of motion. What is the third law of motion? Every action there is an equal and opposite reaction. Every action there is an equal and opposite reaction. Next, there are some situations are given in here. What are they? First one, a man jumps from a boat to the shore. A man jumps from the boat to the shore. Okay. Then what is the action here? What is the action here? Yes, the man exerted force on the boat. The man exerted force on the boat. The boat moves backward. The man exerted force on the boat. The boat moves backward. Here it is the action. What is the reaction here? The boat exerts an equal force on the man in opposite direction. The man lands on the shore. That is the reaction. The second situation, a bullet is fired from a gun. A bullet is fired from a gun. What is the reaction action? The bullet moves forward. That is the action. The bullet moves forward. That is the action. What is the reaction? That yes, the bullet exerts an external force. That time gun moves backward. That time gun moves backward. That is the reaction. Okay. Then what is third situation? A boat is rowed. Third situation is a boat is rowed. Now what is the action here? A boat is rowed. What is the action here? Water is pushed backward. You know that? Water is pushed backward. That time what is the reaction? Yes, the boat moves forward. Action is water is moved backward. That time boat moves forward. That is the reaction. Is it? Yes. Then here we can see that every action there is an equal and opposite reaction. Now according to Newton's third law of motion, we can write F12 is equal to minus F21. F12 is equal to minus F21. F12 is the force exerted on first object to the second object. F21 is the force exerted on second object to the first object. Is it? So we can write F12 is equal to minus F21. Then find out the objects which supply the reaction every activity. Find out the object. What are the objects here? Here reaction supplied by water. Here reaction supplied by first situation reaction supplied by boat. Second situation reaction supplied by bullet. Then third situation reaction supplied by water. Yes, like that. Next there is a question. According to Newton's third law of motion, action and reaction equal and opposite, but do they cancel each other? Why is it so? Yes, we know that Newton's third law states that every action there is an equal and opposite reaction. So, if they are same, also same and opposite, then why don't they cancelled each other? What is the reason of that? Yes, we can see that in first situation, action takes place in boat. A man jumps from boat to the shore. Action takes place to the boat, but reaction takes place where? Yes, on the main. Action to the boat, reaction to the main. In second situation, action to the water, reaction boat. Action to the water and reaction boat takes place on boat. Then a boat is rowed. What is the action here? Yes, action takes place. A bullet is fired from a gun. What is the action there? A bullet is fired from a gun. Which object will get action? Yes, action takes place on bullet. Reaction takes place on gun. Like that. In every situations we can see that action and reaction takes place in different objects. Is it? It takes place in different objects. So, they do not cancel each other. Understand? Okay. Next, law of conservation of momentum. Yes, you can see that figure 3.18. First, using a wiring channel length for marbles, perform the following activity as shown in figure. What is first? Move the first marble slightly back and roll it forward. What happens? First marble backward and slowly back and roll it forward. What happens? Yes, in this side first marble go forward and come to same position like that. Is it? Yes. Understand? Yes. Next, bring the two marble together and let them roll. What happens? Two marble move from other side. If we take one marble move, that time this side also one marble move. If we in this side if we push two marble, that time here also move two marble. Is it? Two marbles also go to other side. Understand? Yes. Next, for understanding that you have an activity. Yes, take different masses. Consider two bodies A and B. Consider two bodies A and B. Consider two bodies A and B of masses m1 and m2. Masses m1 and m2 moving with velocity u1 and u2. Moving with velocity u1, u2 in the same direction is in a straight line. Is it? Yes. Is it before collision? Before collision. Then after collision, say A, B. M1, M2 same, M1, M2 same. U1, U2 changed into what? Yes. After collision, U1 changed to V1, this changed into V2. Then what is the total momentum? We want to find out the total momentum. Is it? We want to find out the total momentum. This is before collision, this is after collision. Yes, according to Newton's third law, F12 is equal to minus F21. F12 is equal to minus F21. Yes. What is the total momentum before collision? What is the total momentum before collision? M into U1 plus M2 into U2. M1 into U1 plus, M1 into before collision, M1 U1 plus M2 U2. Total momentum after collision. Total momentum after collision, M1 V1 plus M2 V2. So, what is the initial momentum? Here said the what is the initial momentum? M1 U1. Initial momentum before collision, yes, M1 U1. Then what is the final momentum of A? What is the final momentum? M1 V1. Initial momentum M1 U1, final momentum M1 V1. Yes, what is the change in momentum? M1 V1 minus M1 U1. All of you write that in your textbook. Change in momentum M1 V1 minus M1 U1. Like that, find out the equation on in the case of B. Here we said in A. In A, M1 V1 change in momentum M1 V1 minus M1 U1. In B, what is the change in momentum like that? M2 V2 minus M2 V2 minus M2 U2. So, what is the rate of change in momentum? Rate of change in momentum M2 V2 minus M2 U2 divided by T. Is it? Yes, FAB and FBA. We want to find out FAB and FBA. You can see that your textbook have FAB is equal to, we know that FAB is equal to minus FBA. FAB is equal to minus FBA. FAB what? M1 V1 minus M1 U1 divided by T. FBA M2 V2 M2 U2 divided by T. There are so many derivations here. All of you write that. That time you can understand. M1 V1 minus M1 U1. This T and this T cancelled each other. We can write minus M2 V2 minus plus M2 U2. Then after we will get M1 V1 plus M2 V2 is equal to M1 U1 plus M2 U2. Here we can understand that total momentum after collision is equal to total momentum before collision. Total momentum after collision is equal to total momentum before collision. This is the law of conservation of momentum. This is the law of conservation of momentum. Next, you can see that there are other problem. A bullet is fired from velocity v from the gun of mass m. Gun of mass m, what will be the recoil velocity of the gun? We want to find out what will be the recoil velocity of gun. Is it? Yes. Okay. Yes, next there is a problem related with a bullet. What is that? A bullet is fired with a velocity v. Bullet fired with a velocity v from a gun of mass m. Gun of mass capital letter m. Gun of mass capital letter m. What will be the recoil velocity of the gun? What will be the recoil velocity of the gun? How can we find out recoil velocity of the gun? Yes. Total momentum before firing. What? Total momentum before firing. There is no momentum takes place here. So, we can write that 0. Then total momentum after firing. Yes, we know that m1 v1 plus m2 u2. That time what will get? Yes, total momentum after firing. After firing, here capital letter M, capital letter V. What is capital letter M? Yes, the mass of gun. Is it? Mass of gun and velocity plus small letter mv. The bullet mass is small letter m, its velocity small letter v. Is it? Yes, we know that total momentum after is mv plus mv before 0. So, we can write it 0 is equal to mv plus mv. That time we can write mv is equal to minus small letter mv. So, what is v? Minus mv divided by m. So, the recoil velocity minus mv divided by capital letter m. Then what is recoil velocity? Recoil velocity minus mv divided by m. Minus sign indicates it moves backward. Okay? Yes. Next, suppose a child of mass 40 kilogram. Next, there is a problem related with this. Suppose a child mass 40 kilogram momentum on horizontal surface with a velocity 5 meter per second. The mass of 3 kilogram. All of you read that and what will be the answer? How to find out? Here we want to find out what? Yes, total momentum. Is it? How to find out total momentum? So, before here total momentum of child and skating board before jumping will be. What happen? What will get? All of you read this question, then you can understand. Yes, total momentum before jumping will be, before jumping is equal to 40 into, what is 40? What is the weight of that boy? 40 kilogram into 5 meter per second. Its velocity 5 meter per second plus 3 is the weight of that skating board. Is it have velocity before? No. So, write 0. Then what happen? We get 200 kilogram meter per second. We get 200 kilogram meter per second. Yes. Then after here total momentum when we start moving at that time, what is the momentum? Yes, 40 plus 3. There are two weights, 40 plus 3 into u. 40 plus 3 into u kilogram meter per second. Is it? We know that before and after that are equal. So, we can write 43u is equal to 200. You get u is equal to 200 divided by 43. We get plus 4.65 meter per second. Plus 4.65 meter per second. Yes, we get u is equal to plus 4.65 meter per second. All of you do this in your home in your notebook. Okay? Is it? Yes. Now, we are going to wind up today's class. All of you do this work in your notebook properly. Okay? Thank you.